In this PPTs, I will tell you about what are amines. Actually, the chapter belongs to Chemistry 5th A for final year students. Okay, what are amines? Amines are organic compounds which contain NH2 functional group. That is, it is the functional group of the amines. So the general formula of amines is RNH2 or NH2, where R is the alkyl group or aryl group. If it is alkyl group, then the examples of alkyl groups are methyl CH3, ethyl C2H5, propyl C3H7, etc. If you substitute all these alkyl groups in the place of R in the functional group of amines, then we can prepare a number of examples. Example 1 is CH3NH2. Another example C2H5NH2, like that. Next slide, please. Now we are studying about the classification of amines. Amines are classified into 4 types. One is primary amines, second one is the secondary amines, third one is the tertiary amines, fourth one is the quaternary amines. In primary amines, the amine group is attached to only one carbon atom. So the example of primary amines are CH3NH2, that means methyl amine, or ethylamine C2H5NH2, like that. Okay. Now, what are secondary amines? Secondary amines are those compounds in which amine group is attached to another 2 carbon atoms. That compounds are called as secondary amines. Examples: CH3 twice of NH. Similarly, the type 3 is tertiary amines. Tertiary amines in which the amine group is attached to another 3 carbon atoms. Example: CH3 tries N. The fourth type of amine is quaternary amines, in which the amine group, that means nitrogen, is attached to another 4 carbon atoms. So the example of quaternary amines is CH3 4N+. These are the classification of aliphatic amines. Another slide, please. Now we will see about the classification of aromatic amines. The primary aromatic amines example is C6H5NH2. It is a primary aromatic amine because here phenyl group is there and amine group is attached to only one carbon atom, so it belongs to primary amine. Next one, in secondary amines, the example of secondary amines is C6H5 twice of NH. This belongs to secondary amines because the nitrogen atom is attached to another 2 carbon atoms. So it is a secondary aromatic amines. Similarly, tertiary aromatic amines in which the nitrogen atom is attached to another 3 carbon atoms. Example is C6H5 tries of NO. The quaternary amines in which the nitrogen ion is attached to another 4 carbon atoms. The example is C6H5 fourth of N plus ion. Next slide please. Now we are studying about the basic nature of amines. Generally, amines are bases according to Lewis theory because all amines donate its pair of electrons to another species. For example, you take the ammonia. It donates its lone pair of electrons to another species. You observed in the following reaction. When ammonia is dissolved in water, then it gives the ammonium hydroxide, NH4OH. In this reaction, ammonia donates its lone pair of electrons to the water molecule. So here ammonia is acting as Lewis base. In this way, all amines containing lone pair of electrons so act as bases, Lewis bases. Next slide please. I take the primary amine, that is methylamine. It is a very strong base than the ammonia because here nitrogen atom containing some electron density. At the same time, the methyl group also donate its electrons to the amine group. Hence, more electron density is accumulated on the nitrogen atom. So, methylamine easily donate its lone pair of electrons to the another species. Hence, it is a more basic than the ammonia. In the ammonia, there is no any alkyl groups to donate to increase the electron density of the nitrogen atom. But in the methylamine, one alkyl donating group is present. It increases the electron density on the nitrogen atom. In this way, if the alkyl groups number is increases, the basicity of amines is increases. For example, I take the secondary amines. Next slide, please. CH3 and HCH3. It is very strong base than the primary amines because here nitrogen containing some electron density. At the same time, here two electron donating alkyl groups are present. These two electron donating groups donate its electrons to the nitrogen atom. So more electron density is accumulated on this secondary amines. So this compound very capable to easily donate its lone pair of electrons to another species. Hence it is more basic than the primary amines. Because in the secondary amines, two alkyl groups are present. So it is more basic. Next slide please. I take the example tertiary amines. In tertiary amines, 3 alkyl groups are present. These 3 groups donate its electrons to nitrogen atom. More electron density is present on nitrogen atom in this amine. So it is easily donate, very easily donate its lone pair of electrons to another species. So it is more basic than the secondary amines. So the order of basicity of the amines is, next slide please. Ammonia is less than, methylamine is less than, dimethylamine is less than trimethylamine. But actually, the basicity of tertiary amines is less than the secondary amines. It is due to the In tertiary amines, three bulky groups, three alkyl groups are present. These three bulky alkyl groups occupied more space on the nitrogen atom. So, the incoming electron deficient compounds does not approach the nitrogen atom because these bulky groups repel, does not enter the electron deficient compounds into the nitrogen atom. Hence, the nitrogen atom does not donate its lone pair of electrons, even though it containing more electron density. This effect is called as steric hindrance. Due to steric hindrance, the basicity of tertiary amines is less than the secondary amines. So the correct order of the basicity of the amines is NH3 is less than, primary amines is less than, tertiary amines is less than secondary amines. Okay, thank you. In the next video, I will tell the preparation and properties of amines. Thank you so much. Thank you, one and all.